Laws of logarithms. Do not forget to subscribe. We have learned some rules for exponents. Since the inverse of a logarithmic function is an exponential function, there are similar rules for logarithms and they always go hand in hand. Since logarithms are exponents, the laws of exponents give rise to the laws of logarithms. Using the law of the exponents, we can obtain the law of the logarithms. First, consider two positive numbers x and y written as x equals a raised to the power of p and y equals a raised to the power of q. Now let's write each exponential equation to its equivalent logarithmic equation. We will multiply x by y. Simplify by applying the product rule of exponent. That is, copy the common base, then add the exponents. We get an exponential equation. Now write this exponential equation in logarithm form. Finally, we substitute back the expressions for p and q in logarithm form to get the first law of logarithms. This law states that the logarithm of a product of numbers is the sum of the logarithms of the numbers. To obtain the second law of logarithms, we are going to do almost the same thing. Pay attention. We will divide x by y. Simplify by applying the quotient rule of exponent. That is, copy the common base, then subtract the exponents. We get an exponential equation. Now write this exponential equation in logarithm form. Finally, we substitute back the expressions for p and q in logarithmic form to get the second law of logarithms. This law states that the logarithm of a quotient of numbers is the difference of the logarithms of the numbers. Consider the positive number x written as x equals a raised to the power of p. Now let's write this exponential equation to its equivalent logarithmic equation. We start by writing log base a of x raised to the power of k. Replace x with a raised to the power of p. We apply the rule for power of a power. That is, we copy the base and multiply the exponents. Remember of this property of logarithm. So replace p with log base a of x. We get the third law of logarithms. The logarithm of a power of a number is the exponent times the logarithm of the number. The third law is an especially useful rule because it turns the exponent to a product, and the products tend to be simpler than exponents. This property is useful in many situations. The laws of logarithms remain the same when working with the natural and common logarithms. Use the laws of logarithms to evaluate each expression or write as a single logarithm. We can see the sum of the logarithms. So we apply the first law. Replace x with 2 and replace y by 32. We write 64 as a power. And now we use the property. The answer is 3. We can see the difference of the logarithms, so we apply the second law. Replace x with 24 and replace y by 8. We divide 24 by 8, and we use the property. The answer is 1. First, we apply the third law in reverse. We can see the difference of the logarithms, so we apply the second law. One is the answer. It looks like there are so many things going on at the same time. First, check if it's possible to simplify each of the logarithmic numbers. In the middle term, we can apply the third law again in reverse. After simplifying, we use the first law followed by the second law. The answer is log base 2 of 3. For some purposes, we need to change the base of a logarithm, and there is a formula that enables us to do this. Change of the base is especially helpful when using a calculator to evaluate a logarithm to any base other than 10 or e, because the most calculators only directly calculate common logarithms and natural logarithms. For example, to find the value of log base 7 of 30, we must change the base of the logarithm first. Change of base formula. Let's start by writing x equals log base a of c, y equals log base b of c, and z equals log base b of a. Write the logarithms in exponential form. We know that a raised to the power of x equals c. In that equation, we replace a with b raised to the power of z, and replace c with b raised to the power of y. So we get an exponential equation. We equate the exponents and solve for x. Now we replace x with log base a of c, y with log base b of c, and z with log base b of a. That's the change of base formula. We can now evaluate a logarithm to any base by using the change of base formula. To express the logarithm in terms of common logarithms or natural logarithms, and then using a calculator. As an example, let's use the change of base formula to evaluate log base 3 of 7 to 3 significant figures. Change the logarithm to base 10. For base 10 logarithms, the 10 is omitted. Now we use a calculator to evaluate the answer. Use the change of base formula to evaluate these expressions to 3 significant figures. Change the logarithm to base 10. Use a calculator to evaluate the answer. Change the logarithm to base 10 and use a calculator to evaluate the answer. If log base b of 2 equals x and log base b of 6 equals y, find in terms of x and y. Log base 2 of 6. Change the logarithm to base b. and replace log base b of 6 with y and log base b of 2 with x. Change the logarithm to base b and replace log base b of 2 with x and log base b of 6 with y. Change the logarithm to base b. Twelve is 2 times 6. Apply the second law. Replace log base b of 6 with y and log base b of 2 with x.